Family Science Discussion Plan. Veronica Vasquez, ECD 322, Cognition and General Knowledge, Science, Math, Logic, and Reasoning. Catherine Casey, March 1st, 2026. Culturally sensitive communication. To ensure my plan is culturally sensitive and responsive, I will build on families' home science and numeracy practices, connect learning to daily routines and relationships, follow multicultural principles that honor culture, language, and identity, use culturally responsive strategies to promote belonging and reduce bias, encourage STEM conversations rooted in family traditions, and then adapt communication methods based on family language, access, and comfort level. And then in my classroom, specifically in my chicks classroom, many families speak multiple languages and have diverse cultural traditions. I ensure culturally responsiveness by valuing families as children's first teachers and building on their home routines. Research shows that home numeracy practices shape children's mathematical identities. The Early Childhood Learning and Knowledge Center explains that science and math begin in everyday relationships. I follow multicultural principles and use strategies that promote belonging, reflect on my own assumptions, and adjust communication to meet each family needs. Building family relationships. I build relationships by communicating daily at drop-off and pickup, using emails, classroom appointments, and conferences for ongoing dialogue, sharing documentation of science and math learning, valuing home numeracy practices, hosting family math science engagement events, and then implementing culturally responsive communication. And then in my classroom, relationship building begins with daily greetings and consistent communication. I also host Monday morning coffee chats, which provide a relaxed space for families to connect, ask questions, and share about their child's experiences at home. Anderson and Gold explain that home numeracy practices shape children's mathematical identities. So I intentionally ask families about routines like cooking or counting at home. I share portfolios that document inquiry-based science learning, and I host family math nights inspired by the Erickson early math collaboration using culturally responsive strategies. I focus on listening, consistency, and mutual respect. Challenges and solutions. Some challenges are limited time at pickup, language barriers, families unsure about the early STEAM, families not open to engaging, families under stress resources, and foster non-traditional households. Some resolutions would be offer quick science, math highlights, and follow up via appointments. Use visuals, translation tools, simple STEAM examples. Explain counting inquiry are developmental, and then start with child strengths and build trust, and then share low-cost home ideas. Use inclusive language and flexible communication. And then in my classroom, families may face challenges such as limited language differences, stress, or uncertainty about early science and math learning. Following the multicultural principles, I ensure communication is respectful and accessible. When families enroll, they receive information about our program structure, including the extracurricular activities incorporated into our afternoon program. So expectations are clear from the beginning. I also provide weekly classroom updates so families know what science and math learning is happening. If families are hesitant to engage, I begin by highlighting their child's strengths and interests. For families experiencing stress, I share simple, low-cost STEAM ideas that connect the everyday routines to my goal is to maintain open, consistent communication and build trust through empathy and transparency. Family support and resources. Supporting science and math learning at home, take-home STEAM activity bags, counting and number sense ideas routines, weekly classroom updates with photos of inquiry and counting activities, Monday coffee chats and family math science nights, printed newsletters and digital appointment communications, community-based ideas like math walks. And then to support families at home, I provide simple hands-on materials such as take-home STEAM activity bags using everyday items. I share number sense strategies families can use during daily routines like snack time or cooking. I send weekly classroom updates with photos showing inquiry, counting, collections, and problem solving in action. I also host Monday coffee chats and family math or science engagement events inspired by the Erickson Early Math Collaboration. I understand that families have different access levels and schedules. I also offer multiple communication methods, printed newsletters, digital appointments, and in-person conversations. Community-based ideas like math walks help families see that learning happens everywhere. My goal is to provide accessible and culturally responsive supports that meet families where they are. Classroom science in action. Children are scientists when they observe and describe changes, ask to question and investigate, predict outcomes and test ideas, solve problems through trial and error, count, compare, and measure during exploration. Science across daily routines, snack time, counting, comparing quantities, predicting more or less, literacy, engineering solutions during story problems, free play, building structures and testing balance, small groups, counting collections and sorting by attributes, and then outdoor play, nature walks, observing patterns. And then science across daily routines, blocks, magnifying glasses, measuring cups, sorting bears, natural materials, and counting trays. And then in my classroom, children demonstrate scientific thinking daily through hands-on exploration. When we plant seeds or observe insects outdoors, children practice observation and questioning, which the Early Child Learning and Knowledge Center identifies as fundamental science skill. During block play, showing test balance and redesign structures, showing problem solving and engineering skills, and small group counting, collection, strengthens, number sense, and reasoning. The Head Start Early Learning Outcomes Framework highlights scientific inquiry, reasoning, and number concepts across daily routines. I communicate these connections to families so they understand that science and math are integrated throughout the day. Head Start Science Domains. Head Start ELOF Science Domains, scientific inquiry, reasoning and problem solving, exploration and investigation, physical science. Connection to daily routines would be during snack time, inquiry, observation, and prediction, literacy, problem solving, investigation, free play, engineering, physical science, small group, inquiry, data collection, and then outdoor play, exploration, and cause and effect, family communication, connection, share weekly examples of inquiry and reasoning, explain subdomains in family-friendly language, and then connect classroom skills to home routines. And then Head Start Early Learning Outcomes Framework identifies key science subdomains such as scientific inquiry, reasoning and problem solving, and exploration. In my classroom, these skills are integrated throughout the day. During snack, children predict and compare quantities. In free play, they build and test structures, demonstrating physical science and engineering concepts. Outdoor exploration supports cause and effect. Understanding, I explain these subdomains to families using everyday language so they see how their child's questioning, experimenting, and problem solving connect to developmental goals. By linking ELOF subdomains to daily routines, I straighten family understanding of how science learning happens naturally and consistently. Family questions and prompts. Family questions. What questions does your child ask at home? How does your child count, sort, or compare objects during daily routines? What happens when something doesn't work the first time? And what does your child notice during walks or outdoor time? And how do you respond to your child's why questions? And then follow-up reflection prompts would be, how could you extend that curiosity with another question? What routines already support scientific thinking? And then what simple materials at home could support experimenting? And how does your child show problem-solving skills? And then family communication connection. I use these questions during conferences, coffee chats, and informal conversations to help families recognize that science already happens at home. Inquiry-based conversations support children's thinking. When families talk about counting during cooking or noticing patterns outside, they are building number sense and observation skills. The Early Childhood Learning and Knowledge Center emphasizes that exploration begins in daily routines. And then these prompts guide families to reflect on how they already support scientific thinking and encourage them to extend curiosity through meaningful conversations. Ongoing family involvement. Families provide feedback through appointment messages, weekly updates, Monday coffee chats, parent-teacher conferences, surveys, and informal conversations. I track children's science and math progress through portfolios with photos and work samples, anecdotal note, inquiry, or problem solving, counting collections, documentation, and then the ELOF online observation checklists. I share feedback through weekly classroom updates, monthly learning highlights, conferences twice per year, and informal daily check-ins. And then ongoing family engagement is maintained through consistent two-way communication. Families provide feedback through appointments, messages, coffee chats, and conferences. I document children's inquiry and scientific thinking using portfolios and anecdotal notes with aligned with inquiry-based learning practices. I also track counting collections and number sent development. I connect observations to the Head Start Early Learning Outcomes Framework. Weekly updates and regular conferences help families see growth over time. And then in my classroom, consistent communication, documentation have strengthened trust and increased family participation in science and math learning. Reflection and AI statement. Planning this discussion helped me become more intentional about connecting science, number sense, and culturally responsive family engagement. I now see how everyday routines in my classroom and at home support inquiry, problem solving, and mathematical identity development. This process helped me reflect more deeply on how I communicate science and math learning to families. Modules 2 and 7 reinforce that children's mathematical identities are shaped through home experiences and that inquiry begins in everyday routines. Creating this plan allowed me to intentionally align my classroom practices, such as coffee chats, weekly updates, and documentation, with culturally responsive principles. This reflection represents my own classroom experiences growth as an educator. And then my AI statement, AI tools were used for editing support. All reflection ideas are my own. And then these are my references I used from modules 1 through 7, are all listed below. Thank you for watching my video. I hope you enjoyed it.